嗯嗯，喂，那喂，大家好，OK, hello everybody, everyone. Yeah, this video I'm going to demonstrate bending stress calculation problem, and it's on your homework. It is this one. Which one? Yeah, it's this one. This one is I choose the 1160. Okay, it's from your textbook. I choose 1160 to do this demonstration, and I think because I think this problem maybe is kind of very difficult to you. Okay, so he say the problem is say there's a beam like this. Okay, there's a beam, and this is the very special cross section of this beam. And he say is the beam the maximum allowable tension tensile is 14 megapascal and maximum allowable compression is 21 megapascal, and determine maximum allowable internal moment. Okay, determine the maximum allowable internal moment. Okay, yeah, I think you have bear this in mind. When you have internal moment in your beam, you will have the compression because is the beam curves up. Maybe I need to do some demonstration. Okay, if the beam is curved up, okay, the upper section is compression and the bottom surface is tensile. Okay, so if there's an internal moment cause the bending of stress, okay, for example like this, maybe not here. If it's like this, okay, the top surface is compression and the bottom surface is a tension. Okay, so that's why it give you the maximum allowable tensile and compressed stress. Okay, and okay, he say want to calculate the maximum allowable internal moment. Okay, and so yeah, I already draw the cross section of this problem. Okay, okay, so that's the cross section of this problem. Okay, so let's say first of all, what's the relationship between the bending moment and the bending stress? Yeah, in the class in the problem we say the bending stress is equal to minus my over I. Okay, you remember that? Okay, I think you got to remember this. Okay, so that's the relationship between the bending stress and internal moment. And y is the distance from the neutral axis. Okay, so for this problem, the first priority is finding the neutral axis. Okay, so let's start to look for the neutral axis. Okay, so the neutral axis, okay, the calculation for neutral axis is very similar to do the centroid calculation for your composite area. Okay, so this is a complicated shape of the core cross section. Okay, but we can divide this complicated shape into a simple shape first. So in this problem, he's already cut the shape for you. Okay, he divided the complicated shape into a simpler shape for you. Yeah, this complicated shape we can divide into four rectangular shape. Okay, a four rectangular shape. Okay, and after you divide this complicated shape into the simple shape, okay, the next thing is identify the centroid of each section. Okay, so how to the centroid of the rectangular shape is very easy, right? The centroid of rectangular shape, yeah, the centroid is here, the centroid is here, the centroid is here, and the centroid is here. Okay. Okay, so how to calculate with so the next thing, okay, how to calculate. Okay, so how to get neutral axis. So if we set this is the coordinate here is 0. Okay, 0. Okay, so the centroid is the distance from the base. Okay, so it's in y direction. So where should I put this? Okay, maybe I put here. So the y bar is equal to summation I ai and summation ai yi. Okay, and then we label these four sections. We have four sections, so this is going to be a long time calculation. So I say this is a one, this is two, this is three, and this is four. Okay, so let's start to do the calculation again. So we have four different sections. So it's equal to A1 plus A2 plus A3 plus A4. So, and then A1 Y1 plus A2 Y2 plus A3 Y3 plus A4 Y4. Okay. Okay, so let's start to find each term. Okay. So what's the A1? Okay, A1 is 25 millimeter times 75 millimeter. Okay, 25 millimeter times the 75 millimeter. Okay, so and then what's the A2? And actually A2 is actually exactly the same as the A1. So okay, maybe we can calculate is first. If you use your calculator correct, it's 1.875 times 10 to the power minus 3, and it's m squared. And A2 equal to A1. Okay, so its dimension is the same. So okay, so we don't have to calculate again. And what's the A3? What's A3? Is A3 its width is 150. 25, so we add this together, it will become 200. Okay, so it's 200 and times the height. What's the height? It's 25 here, so it's 25 millimeter. Okay, maybe I put it here. Okay, so what's the value here? So if you just use your calculator again, it is just now right now just told you the answer is 5 times 10 to the power minus 3. Okay. Okay, so the next thing, maybe I should zoom in this. Okay, so what's the next? So what's the A4? Okay, A4 is the width is 25 millimeter and the height is 100 millimeter. So it's 25 millimeter times the 100 millimeter. Okay, so yeah, once I can use your calculator, it's going to be 2.5 times to 10 to the power minus 3. Yeah, it's all meter square. Yeah, we have A1, A2, A3, A4, but that's not enough. We also need Y1, Y2, Y3, Y4. Okay, this is the Y coordinate of the centroid of each area. Okay, Y coordinate of the centroid of each area. Okay, so okay, then we will start. Okay, what is Y1? What is Y1? The centroid here. So Y1 is here. Yeah, be careful. So it's 75 divided by 2, right? So okay, so it's 37.5 millimeter. Okay, and Y2 also equal to Y1 is equal to 37.5 millimeter. Okay, and unit is m. Okay, that's Y1 and Y2. What is Y3? Be careful. Okay, Y3 is the coordinate of Y coordinate of centroid for area 3. Okay, so what is Y3? So the centroid is here. The Y coordinate, the centroid for area 3 is here. So the Y coordinate is here. So this is a 75. Okay, and what's the distance here? It's 25 divided by 2. So be careful, be careful. You have to be really careful for this such calculation. Y3 is 75 millimeter plus 25 divided by 2 and times 10 to the power minus 3. So what's the value of this? Okay, it's 87.5 times 10 to the power minus 3 meter. Okay, the final one is what is our Y4? Y4, yeah, here. The centroid is here. Centroid of area 4 is here. So your Y4 must be here. Okay, this is centroid of area 4. So your Y4 is here. And so be careful, our base is here, our reference axis here. So it's 75 plus 25, and here I think it's 100 divided by 2. So it's 75 plus 25 and plus 100 divided by 2. So that's Y4. So is 75 plus 25 and plus 100 divided by 2 and times 10 to the power minus 3. Okay, so that's y4. So what's the y4? Let me see. 75, 25, 75, 25, 50. So it's 150, 10 to the power minus 3. Okay, so we have y1, y2, y3, y4, a1, a2, a1, a2, a3, a4. Okay, so what's our y bar? Y bar is, yeah, it's very it's very numerical. So it's a1 10 to the power minus 3 and a1 a2 is the same, so it's 2 times 1 up. Sorry. 2 times a 1.75 10 to the power minus 3 and plus a3 is 5 times 10 to the power minus 3 4 a4 is 2.5 times 10 to the power minus 3. Okay, so and then a1 y1 plus a2 y2, actually a1 y1 and a2 y2 actually they are the same, so that's we use 2 times a1 y1, so it's a1 and y1. Okay, this a1 y1 plus a2 y2 actually they are the same, so 2 times a1 y1 will be fine. Okay, and a3 y3, so a3 y3 is 87.5 10 to the power minus 3. Okay, so final last term a4 y4 a4 a4 y4. Okay, so right now, so just use your calculator. Yeah, what's the answer for the y bar? Oh my god, let me see. Okay, so let's see. We will have I think the denominator will be, let me check my notes. I believe my notes is correct. Okay, so 11.25 times to the 10 to the power minus 3. And this will be 140.625 times 10 to the power minus 6 plus 437.5 10 to the power minus 6. Okay, and then 375 times 10 to the power minus 3. Okay. So so we keep doing the calculation. So yeah, this all 10 to the power minus 6 looks very nice. So just add these 3 terms. So you will have 953.125 times to 10 to the power minus 6, so an 11.25 times to 10 to the power minus 3. So what's your answer? Your answer will be 84.72 times 10 to the power minus 3. Oh, sorry. It's m. Okay. And it's equal to mm, 84.72 mm. Okay, don't forget a small small m is 10 to the power minus 3. So that's the position of the neutral axis, 84.72 millimeter. So where is it? 84.72. Let's go back to this cross section. 84.72. 84.72. Okay, where is 84.72? Here is 75 and here is 25. So here is 100. So 84.72. 84.72. I think 84.72 is here. 84.72 is here. It's hard to. Yeah, 84.72. It's about yeah, that picture is too small, but maybe in the next video I will zoom in. But right in this video I just draw very sketchy. Okay, 84.72 is here. Okay, here is 84.72 millimeter. It's above 75, but it's below than 20, below the centroid of area 3, because here is 12, it's 12.5, so 12.5, so it's 87. 12.5, so here is 80, so the centroid of area 3 is 87, here 87.5 millimeter, but our neutral axis is 84.72, so it's a little below the centroid of area 3, a little below the area of a little below the centroid of area 3. So it's probably, yeah, it's very close to here. Yeah, but the picture is too small. So I'm sorry. I'll draw a big picture next the next video. So this problem is huge. So I just start a video for the first section. So first problem, we find a neutral axis. Okay, and then we'll continue to the second video. I think this problem needs 3 video. Okay, we'll go to the next. So I'll just stop the first section, and I'll continue the section, continue the second section in the next video. So, okay, so I just pause the video or start the video here, and see you in another video. Bye bye. Okay.